I love the view up here. What's this? Not again. This time I got a Hotronic AP41 time base corrector. This is a device that would have been used in a broadcast setting to correct the time base on videotape for broadcast, or to correct time base on videotape that need to go into a production switcher to have things like titles and so forth added. It also has a proc amp built in. This one here is not working. It's just dead. And we're going to see if we can get this one going. Check it out. Today I have a Hotronic AP41 time base corrector to check over and rebuild. Apparently. I guess we'll see what's wrong with it. And see what it needs. I've got one of these units myself. I never use it. Personally, I'm not a big fan of time base correctors because they're not really necessary unless you are doing specific things. And I do have a frame store if I need to do specific things. But time base correctors, all of them, they have a tendency to degrade the quality of the picture, which is kind of what you're trying to preserve when you're digitizing. Some cards don't like video that's got timing errors in it, and for those type of cards, then yes, these things can make the difference between being able to get a capture and not. But the better cards, they have their own internal time base corrector as part of the digitizer, because that is how these work. Okay, a time base corrector is nothing more than a device that digitizes the incoming video, puts it in a memory, and then reads it back out of the memory using a stable clock. Right? You digitize a video signal that's got timing errors, you correct the timing errors, and you read it back out. So any capture card that's worth being called a capture card already has that built in. When they digitize, they can correct the timing errors as they are saving. Only some of the cheap ones have a problem with that. So first things first, I'll get this hooked up and we'll see what the video looks like going through it. Yes, they do have the ability to adjust your chroma phase and your video level and your chroma and so forth, but that's about it. You can do that with a proc amp as well, and you can also do it in software once you've digitized it. And from what I've seen, the setup in software, it does a heck of a lot better job when you're working on it offline, where you can play around with your color balance and do all kinds of neat stuff to the video once it's in the digital domain. The downsides to a lot of these units is, yes, they have YC in, but they don't have YC out. So they're going to take your S video, your separate Luma and Chroma signal, and they're going to combine them into a composite signal. Feels like that's kind of loose, but we'll find out when I get this plugged in. We'll find out what it's doing. I'm going to plug it into. I'll just use a color bar generator on it initially just to see how it's looking, and that way we can evaluate it with color bars. So this unit is totally dead. No power, except for when I bang on it. So we got a power issue on this one. Let's pop it apart and see what's going on with it. The fact that the unit was missing a screw is a good indication that someone's been into this unit and worked on it. Yikes, all the EEPROMs have their window exposed. Those should be covered up because exposure to ultraviolet light will erase those chips and render this thing useless. Good thing the lighting in here doesn't have a lot of UV. It's mostly LED lighting that I've got here. No power. Let's check the power supply and see whether there's any juice coming off the power supply off the DC side of things. These units go into a bypass mode when the power is off. I remember mine, the relay was bad on it. I still haven't got around to replacing it because I don't use the unit. It's kind of, let's see what the power supply is doing. See whether this thing's putting out enough juice or whether we've got cap issues on the power supply. So we'll just ground the meter and we'll just do some voltage measurements. Nothing there. See the meter? Can you see the meter? And it's jumping on and off. So we have a power supply that's not starting. See? So we got an issue in this power supply. it's not booting up. So now we know where we have to start. We'll get into that power supply. The ports need to be resoldered. You can see cracked solder down here, so the ports need to be resoldered. That's one of the problems, but that's a relatively minor problem. I got to get the power supply working first. And it's going to be a capacitor for sure. It's probably going to be one of the ones here in the primary. Somewhere in the bootstrap that boots the power supply up is going to be where the failure is. So got it unplugged now. We'll rip out the power supply and see what's going on. I don't see any bulge caps, but they don't have to be bulged to have a problem. They can also have high ESR. Toasty. Yeah, it's been a bit warm. What do you think? Looks to be that this has been a little bit on the warm side at some point. And wonderful. I guess I can. Oh, it looks like this power supply has actually even been replaced at one point. Wires have been spliced here. Look at this. Yeah, someone spliced this wire. Where the heck? Oh, that goes to the power switch. That goes up to the power switch. All right, so I can pull this power supply out of here completely and work on it separate out of the box. Put this thing out of the way because this isn't kind of big to be here. Although I might need to put a load on it to test it, but I'm thinking maybe one of these little caps like this one down here. This is going to be in the oscillator circuit. So this is one of these ones is likely. One of these little ones here is likely what's the cause of the fault on this one. That's what we're going to check first. Let's look at the power supply. It's got some of that crap circuit glue on here, as you can see. That doesn't. I don't know if that's glue or whether that cap is leaking. I think it's glue. But I'm going to pull this little board out, turn on the old soldering iron, remove the board, and then I can check those caps because it's hard to get at them. They got a plastic cover over the back here to keep them from shorting out against the transformer. I think once I get this power supply running, this unit will probably be okay. I doubt that there's much else that's wrong with it, just a power supply problem on this one. My blood is boiling today about YouTube, and you guys have probably seen the video I just re-uploaded because somebody at YouTube, and I'm going to refrain from using any language that might get me banned, but they really got to give their head a shake. So the bird video at the beginning of the video, the bird that cap there looks like it could be popped a bit. We'll check that one as well. The bird at the beginning that gets jolted. I said Schick, as in the company that makes razors. Schick. Not the one that ends with T, but Schick. Rhymes with ship. I said Schick, not again. Someone thought I said something else and demonetized one video. Or actually didn't demonetize it, made it not suitable for advertising. So I went in and I actually went into YouTube Studio and I edited that word out so that it just jumped from the bird getting zapped to not again. And I requested a review and they said they manually reviewed it and it was offensive and they demonetized it or made it not suitable for advertisers, which is the same thing as demonetizing it. So I got to play their game. I have to upload it again and do the whole video again, and I changed it by about 3 seconds. Took about 3 seconds of material out of it so that it doesn't show up as an identical video, because if you upload the same video a second time, then they get you for what they call it, shadow banning, I guess, when you upload the same video. So I made about a 3 second change to it so that the checksum is different. It's a different video. It's 3 seconds shorter, and I dubbed in crap just to make it, to change it, to put it back up. A bunch of morons, bunch of freaking morons is what they are. The company is run by a bunch of imbeciles, and I'm being nice when I say that because this is absolutely ridiculous. There was a TV show, for crying out loud, that was called Schitt's Creek. There, I said it. It's a surname. Right? It's a surname. And yeah, a bunch of morons. I got my blood boiling over these boneheads. And yes, the bird is okay. Everyone asks, did the bird live? Yes, the bird lived. No, I didn't shoot it. Somebody gave it to me a while back, and I just kind of laughed. It was sent to me probably, I don't know, 6 months or more ago. A friend sent it to me. He thought it was hilarious, and we got a good laugh out of it. And one day I just thought, I can do something with this. And I didn't for a while. I kind of did that little voiceover thing about the same time as the guy in Australia did it, because he did one very similar to it. I don't know who. I think he probably put his up first before me. I did it and sent it out to some friends as a joke, right? But anyway, I finally got around to using it, and it's kind of become a little bit of a hit. So I've used it a couple times. Usually when something is hit with a power surge. It's just that we've had so many bloody bird strikes locally here in the last few months. I live in a migration route for geese and ducks and stuff. So they all come through this area, and they land and they rest and eat and so forth. And then as they're flying south, they all come out and they land in the farmers' fields, because there's farmland around here. And because the fields are, of course, now all cut down, and whatever has been left behind, well, they're going to forage on it. So they land in the farmers' fields. But it also happens to be duck hunting season around here. So there's hunters out there that are shooting ducks and geese. And what happens when you've got a flock of, maybe 20,000 birds in a field, and someone blasts a shotgun? You know what happens with the rest of the flock, right? Boom, they go. And when they take off, they are in a panic state. And when you see birds swarming in a panic state, they don't really pay attention to what they're flying into or around. And they very often go between the wires, and you'll get a couple birds with their wings outstretched, and they'll cross a couple primaries and hit 25,000 volts across the 2 primary lines, and kaboom. Result, you got a cooked goose, literally, and a power failure. And quite often that power failure ends up giving us a nice power surge at the same time, which sometimes blows up equipment. This is a 25 volt 100 microfarad cap. I'm going to go out on a limb and say that this little bugger is bad. So we'll just check it with the ESR meter, but I'm pretty sure that this one's going to be FUBAR, because this is going to be one of the ones in the oscillator circuit. And generally these are the ones that go bad when they don't start properly. 2.9 is what it measures. So it's actually not measuring too bad. It's a 100 microfarad, 2.9. Well, 100 microfarad should be like 1.2. What voltage is this thing? 25 volts. So it should be like 0.32, right? And it's measuring up at 2.9. So 3 ohms. So that cap is definitely FUBAR. There's another one down here. I think this one here probably is also bad. I'm going to measure it in circuit. And this one here is measuring completely open. That one is bad. How about some of the other ones here? We'll just measure them all while I'm at it. That one's probably okay. This is the 2200. This one's be bad too. 0.2, 2.9. Yeah, that one's going to be bad. What other ones are in here? We'll just check them all. Where's the other ones? The one over here. A few of these ones could be replaced. But we'll start out with the ones for sure that we know are for sure bad. I'll check this little tiny one here, because this little tiny one also could be one that's going to be giving us trouble. This little bugger down here is 27, but that is a 4.7 at 50 volts. So 4.7 at 50 volts, 4.2, and that's measuring at 27. So that one's bad. So we'll start out with these three and see what happens. We'll start out with doing these three here. The other ones in here aren't looking to be in really bad shape, but this one here is open. This other little one here might be also bad. That's next to it. It's not. The top's not popped or anything. So. And then we'll see what needs to be done. I may end up just changing all of them. 18, yeah, that one's also going to be bad. Because the guy that owns this thing here, he hasn't really put a limit on what he wants to spend. He just wants it to work. So if we've got to change all these caps out, we'll change them all. But for sure, that one's bad, and that one's bad, and both of these two over here are bad. So we'll start changing those out first and see if it starts up. That was the 4.7. Reinstall the board. You know, these things get hot. Look at the discoloration of the plastic barriers. Like, these used to be clear and they're turned to, well, they've turned black almost. Like, you know, that shows the kind of heat that you get in behind on these the heat sinks and stuff, right? That one went in behind the heat sink there, so that reduced or eliminated the possibility of it short circuiting up against the outside cabinet. But yeah, a lot of heat in these power supplies, and that's why they fail, because they just run so hard. And even though this thing's got a fan on it, a unit like this would have been left running. If it was used in a TV station, this would have run 24 hours a day, 7 days a week. They would never shut this thing off. And it probably didn't have any faults at all until it was shut off. And then once it was shut off and taken out of service and the caps cooled down, that's usually when they won't start back up. So this thing was probably running just fine right up until the point in time when it was turned off. And then at that point, it just wouldn't turn back on again. .47 at 25. This next one is right here. Once I've got these ones done, I will try to power it up, and we'll see what it does. Measure this one out of the circuit. Well, I can measure both of them out of the circuit, but this one's going to be like open. See, there's your problem there. 76 ohms. And where was the other one? Was it this one? Open. No. That was 4.2. Was it this one? Yeah, that one's open. So this one is a 470 at 25. It's a Nikon was the original. 470 at 25. Should have lots of those here. Paying attention to polarity, of course. You don't need any smoke today. So I'll get this remounted and we'll test it and see if it fires up. So I had to put tape over top of the EPROMs because the windows are open on them. It's kind of like a good way to erase the EPROMs from exposure to ultraviolet light. Fortunately, in here, most of the lighting is, well, there is some fluorescent lighting, but most of the lighting here is LED. So there wouldn't be a lot of intense ultraviolet, but I put tape over them just to keep them dark, just for, to be safe. How's this little fan? This little fan is probably shot. Let's see here. Looks like it's going to need some oil. Well, we can oil that up. Mount the power supply first, just so I can verify operation. Pop it back in here. Okay. Let's see if this thing goes boom or whether it turns on. For these connectors to reflow these, it's going to be a big job. I'll either have to pull the board out, pull the whole thing apart, take the front panel off to get the board out, or I might be able to solder them down here because it is a plated through board. Because to redo those connectors by pulling on that board is going to be a huge job, but we'll see. We'll see what happens here. Okay, power is off. Now I will put the video signal through here before I power it up. So I got my output going over to the TV. Got my input coming in from the color bar generator. And I've got video now. And And is it on? No, it's not on. It's still, you can hear it, it's still pulsing. So it's still not starting. You can hear it click, 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 click. That's the relay over here clicking. But in bypass, it won't do that. But the power light is pulsing on the front. You see the light? So we still have a PSU problem on here. So more work is needed on this power supply. More caps maybe. Maybe this other little guy over here. But power supply comes out again. We know where the fault is. It's going to be in the power supply. These two 2200 at 10 volts are bad. They're going up in value, so they will be swapped out. That 1000 at 25 volts is marginal. It's measuring about what it's supposed to. 1000 at 25 volts. It says it should be 0.08, and this one's like measuring 0.1. So it's not high. These ones here are higher. They're bad. They got to be changed out. I will see what I've got in inventory for these caps. And there's another one over here. There's a couple other 1000s. There's another 2200 over here. We'll check them all. But these two here definitely are bad. They're in parallel with each other. And I think there's another one also here in parallel through a coil. So that's probably why I was reading low voltage, because there's another one over here that goes through a coil. And there's another one across here. That's probably the one I was reading the low value on, because there's basically three of them in parallel with each other, and there's a choke coil here. So I was reading this one. Let me find a couple 2200s. I'm sure I've got some kicking around here somewhere that I can swap in there and see what happens. All right, I got a couple here. This is the first one. I got to find another one. These are 10 volt caps, and I got lots of 25s. And the problem with the 25s is they're just too big. They won't fit in the space that's required. So I'm having to go through my parts bin and find some low profile small caps to fit in there. I got one there. I'm looking for another one on some other boards that I've got here. And hopefully I'll have another one. I should have one on a power supply here somewhere. And these ones are testing excellent. See that? 0.02. So there's nothing wrong with this one. It's a good quality cap. This is, what is it, a Rubicon? I think this is a Ruby. The other one's a Ruby. This one should fit in here with enough clearance. Here we go. So I'll change out this 1000 at 25 while I'm at it, since I'm already here. I'll change that one out as well. Okay, we're ready to try this again. The power plugged in, and turn it on. See whether it goes up in flames. You guys would like that, wouldn't you? Alright, power. I got power! And the fan's not spinning. We gotta fix that. It's trying to. It's not turning. But I got power. And I can show you the picture on the TV. Alright, so time-based corrector. Yeah, those are the ports that are loose. If I bypass it, there's it bypassed, and there it's going through the time-based corrector. But in the time-based corrector, I can do things like adjust the gain. It's called the setup. That's the black level. And you'll see what it does to the picture. It actually messes with the 3D comb filter in the TV, because as I'm changing it, it can't separate those colors as well, because I'm playing around with it. But that's the setup. Your video level, you can adjust the video level, and you can adjust the chroma. And of course you can adjust the chroma phase. And that's what a time-based corrector lets you do. And this one is now functional, and it actually looks very good. Of course, to use one of these things, you need a vector scope. You need a color bar generator so that you can calibrate it. Without a vector scope and a color bar generator, well, how do you know that that's right? Right? How do you know that that's correct? How do you know that there's not too much color there, which there is? Right? So, there's a lot of you can select the S video or composite input, and you can change your field 1 or field 2 for your sync, frame sync, or frame. I think it stops it from working there. It gives you like a freeze frame. Oh, that's what that is. That's freeze frame, and this is freeze field. Field sync, F field, freeze frame, or free. I think that's what that is. I don't know. I have to look it up. Anyway, I think that's a freeze frame there. If I unplug the video, it will stay. Right, I unplugged the video going in, and there's still video coming out, so we can freeze a picture. That's what that is. That's why the dot crawl's not moving, because I basically froze a full frame. And in this case, I freeze a field. Anyway, those are modes that you're not generally going to use. What's going to be used on this is just the phase adjustment, the chroma phase, the chroma, and the setup level, which is your black level, and the video level. So I'll put a video signal in here so we can actually see a video signal going through it, not just color bars, so you can see what it does with an actual picture. Okay, so now we're looking at some picture. You can see what I do. This is the setup control. You can see what I'm doing. I'm adjusting the black levels without affecting the video level. Then there's the video gain. The video level affects the white level. So if I'm too hot, you'll see the waves are blown out. So you can adjust it to make it look good. Again, you need to have a waveform monitor and a vector scope to do this properly. Otherwise, you're just guessing. Because if your monitor isn't properly calibrated, you're going to be making the picture look far worse than it originally did. So you need a scope, a proper, like Tektronix 5, I think it's a 529, and a vector scope to do this. Eyeballing it on the TV, yeah, it might look good on the TV, but what if the monitor's not calibrated right? But you can see here, I can bring the color up and take the color down. Bring the color up, I can change the phase. Make the water more blue, make the water more green. But that's what it does. So this one is now functional. I just have to fix the ports, and I gotta fix the fan. Otherwise, this thing's gonna cook again. So let's deal with the fan first, and then I'll deal with the ports. I peel the sticker off the back to expose the motor, and I'll just give this thing a shot of oil and let her spin here a bit. And there it goes. Now, does a time-based corrector make the picture look any better? Yes or no? Can you tell whether the time-based corrector is on or off in this shot? How about that shot? Obviously it's on there because the brightness is a little different than the original, but time-based correctors don't necessarily make the image better. When you get stuff moving around like this, they can actually cause a strobing effect. Let's see if I can turn the strobing off on here. But on that shot, it was pretty blatantly obvious that they don't necessarily make the picture better. It all depends on how you've got them set up. And if you don't have them set up right, they are not going to improve the picture. They are actually going to degrade the picture. Also, this source is a very good source. This is the digital source. So there's not really any analog artifacts that need to be corrected. The time base off of a digital source is already perfect. So the time-based corrector will add artifacts of its own, and that's why there's certain times where you're going to use one, and the rest of the time you don't want one. When I was in broadcast, for example, when we edited our tapes, we did not use a time-based corrector to dub the tapes. We dubbed them direct without the TBC, and the TBC was only used if we had to do things like put titles on, because we needed to have the time-base corrector, we needed to have the video time-base perfect to go through the title or through the switcher. Otherwise the picture would fall apart, it wouldn't synchronize. So we had to, and we had external gen lock. So for things like if we needed to put titles on, we ran it through the TBC. If it was going to the modulator to go broadcast over the cable system, it went through the TBC. If we were just editing a tape, and this was 3/4 inch back in the days, 3/4 inch, and with 1 inch tape. 1 inch we had to use a TBC, that was a must for that. But for the color under Heterodyne system, no, we didn't use it. We kept it out of line, except for in those instances where we needed it for running through the switcher to add titles, for example, or when it was going for broadcast. The rest of the time it was left off. On a shot like that, it's you don't really notice much of a difference. You might notice a little bit of difference. To me, the non-time-based corrected one looks better, but then again, this is the digital source. If this was coming off of a tape, then the opposite probably would be true. If I were to play a VHS tape with this recording on it, which I could, maybe I will. We'll do that just to compare the two. But from a digital source, it doesn't not improve a digital source, which is already time-based perfect. So all we're doing is we're running the video through extra processing, which it really doesn't need, and it doesn't improve anything. I'll dig up a VCR and we'll see how it looks playing a VHS tape. Okay, so now we're looking at a VHS playback of the same recording. It was made from the DVD. That is the untime-based corrected source off the tape. And I'll switch to the TBC. You notice the difference? There's the untime-based corrected. Look at the wiggling of the picture a little bit. And we'll go to time-based corrected. Non-TBC, TBC, and with TBC now I can adjust the levels. I can adjust the white levels, and I can adjust the black levels. I can crush the blacks if I really want, or I can bring the blacks right up into the video level. And of course I can adjust the chroma level as well. I can make that water look more blue, or I can make it look less blue. The idea is to try to make it look as close as I can to the original. So there's the original tape, and there's the TBC tape. I think you can probably notice the difference. Time-based corrector on, time-based corrector off when playing a VHS tape. There is slight differences. They're not huge, but there is a slight difference. Again, if you're using there's off now, now it's on. You'll notice that the edge of the rock here seems a little more pronounced. It's on, off. You see that. You see the jaggies around the edge there of the rock when it's off. Here again, it's off, and I'll switch it on. You see the stability in the fine details. Off, on, off, on. That's what a time-based corrector does for analog tapes, source tapes. So in that case, again, you can get a bit of an improvement. And if you've got a digital capture card, one of these funky ones that gets upset if there's any disruption of the sync whatsoever, it can mean the difference between a great capture and a mediocre, crappy capture. But if you've got a better capture card, or even if you loop through a DVD recorder, even if you don't record it to DVD, if you just loop it through a DVD recorder, they have a full frame store time-based corrector in them that does a very good job. At least the Toshiba and the Panasonics that I have, they do a fantastic job just looping through the recorder. A lot of times when I'm going to DVD or going to USB stick, I'll use my digital 8 camera and I'll output from the FireWire into my Toshiba DVD recorder that has the FireWire in. I'll let it do the time-based correction, and then I can either take the component out, which it's got. Now I think component out only works for, well, it does work. I think it does work for for the digital in. It doesn't do it for analog in, but it does for the DV input. But I can use the HDMI out. I can use my Toshiba to convert to HDMI at 1080p, and then capture that out with my 1080p capture card. And that's what I do when I'm doing 8mm and digital 8. And DV is I just use a FireWire into my Toshiba DVD recorder, and then I can do two things at once. I can burn them a hard copy on DVD and use the 1080 output from the DVD recorder and capture that on my HD capture card and give them a hard copy. And I don't need to use a time-based corrector because it's built in, and the one inside the recorder looks fantastic. I don't have the control, I don't have the setup or the video level control, but I shouldn't need to do that because the video should be correct unless the camera was malfunctioning. And if that's the case, you're really not going to do much to fix it if it's bad. If the sync level or something is wrong, if the camera was malfunctioning, you really can't do a hell of a lot to correct that anyway. But this one's pretty much done. Just have to solder those connectors on the back so that they are a little more tight than they were, and then I can get this one ready to go back to where it came from. It's been here for a while. It was shipped in a few months ago, so I'm finally trying to get cleaned up here with the backlog. So here's the connectors, how bad they are. See? So we're gonna solder those up, fix that problem. I'm going to have to pull the board in order to redo those connections. So I'll pop the controls off. I got to pop off this faceplate first, and then I can remove the screws for the board, lift the board forward and out, and then I can get at the connections on the bottom side and redo them. Okay, now I can remove all the screws to lift the board out of the way. And there are a few of them. Got a bunch of empty space on the board too, but that's because there would have been other models of TBC that had other features that this one doesn't have. Okay, that should release the board now. So I can flip it over and redo these connections on the bottom here. Looks like there's been work done on here. It looks like that part's been changed out or something. Going to redo a regulator here that looks like the connection's not very good on this one. So just redo this regulator while I'm here. These connectors are now nice and tight. These other ones are tight because they've probably never been used, or they haven't been constantly connected and disconnected. That's what happened with the video connectors. I'm going to remount the board now and give this thing a test and get it together and get it out of here. Nice thing about these chassis using these machine screws is that they all go in real quick. You notice that I did keep these screws in separate piles when I was taking them out. That way I could count all the screws as they were coming out and know if I had any extras left over and look for where they would go. So these ones I kept all separate from the rest just to make it easy to see if there was any extras. So they're all back in place. Get the front panel on. Reconnect it and power it up and see how the video looks now on it. The input. Yeah, okay. Yeah, much better. I'll show you guys a picture now. It's not breaking up anymore. So there we go, right? Connectors are nice and solid now. This one's fixed. So that's it. Done. Thanks for watching.